But with number 7, okay, we've got to be slightly more comprehensive in our approach, okay? Because what they're saying here is they're essentially saying, prove that, okay, all square numbers are either a multiple of 4 or one more than a multiple of 4. So we've got two things that arise from square numbers. So if we consider square numbers as like n squared, they're either, okay, a multiple of 4 or, okay, what does it say? One more than a multiple of 4. We've got to prove this. We've got to prove that two conditions arise, okay, with regards to square numbers, okay. So how do we go about this? Well, we need to consider two cases, okay. So let's consider the first case, case 1, when the actual number n is even, okay. So we're going to consider the case when n is even. We're going to square it to see what we get, and then we'll consider case 2 when n is odd, and we'll square that. So if you think about it, if we consider the case where n is even, and then consider the case where n is odd, we've considered all of the possible numbers. So when the n is even, therefore n will equal to, say, 2k, okay, for a constant k, any k. Alright, so when I square it, okay, n squared becomes then, well, if n is 2k, I'm going to square that. So when I square that, I get 2k all squared. So 2k all squared is 2k times 2k, which is 4k squared. And that is indeed a multiple of 4. Okay, so let's consider then the other case. Okay, there's only two cases, isn't there? N is either going to be even, or in the second case, n is odd. So if n is odd, that means then we've got to set n to equal to 2k plus 1, yeah? Okay, because that represents an odd number. So I'm going to square it to see what the square becomes of an odd number. So we've squared an even, but now let's square an odd number. Okay, so when I square an odd number, I get 2k plus 1 all squared. So I'm going to expand this. So write the bracket out twice. Okay, and then I'm going to multiply out. So I get 2k times 2k is 4k squared. Okay, plus the outers, which is 2k, plus the inners, which is 2k, and then plus the last, which is 1. So when I simplify this, then I get 4k squared plus 4k plus 1. And you might see now, in this case, all right, there's something we can do, of course, with the first two terms. Okay, because you've both got a factor of 4, so we can write 4 out, factorize it outside the bracket. Okay, so we have 4k squared plus 1 when I factorize the first two terms there, plus 1. Okay, so what I want you to see here now is that actually the square number is a multiple of 4 plus 1, which is basically the situation it says at the top, isn't it? One more than a multiple of 4. So we can say that that means it's one more than a multiple of 4. So in conclusion, we can consider both cases. We can say, look, when n is even, n squared is a multiple of 4. When n is odd, n squared is one more than a multiple of 4. So we've considered both cases there. We've shown that that situation arises.